this video, we take a look at slope fields. So what is a slope field? It is a graphical representation of all possible solutions to a differential equation. It's basically a graphical antiderivative. It's basically a field of slopes or a coordinate plane of slopes, and that's what we're looking at. Here's our first example. It says dy dx is equal to 2x. So we know that the slope is equal to a linear function. Well, that means the original function is equal to a quadratic. We can use separation of variables to come up with a general equation. And so let's see, I'm going to multiply both sides by dx. So I have dy is equal to 2x dx. So I've separate, now I integrate. And so this is going to give me y is equal to 2x squared over 2 plus c. My 2's will cancel, and I can see that the general solution is x squared plus c, a quadratic with some y-intercept. We can draw that on this coordinate plane. Let's go ahead and make a table of values. And using my slope, let's see, I'm going to go ahead and pick a different color here just so it shows up, x, y, and dy dx. This is what you'll do on each of your problems, is you'll make a table. Now, for this problem, the only thing that's affecting the slope is the x value. So I really don't need to be concerned with this column at all. I'll show you. And let's go ahead and pick some x values fairly close to the origin. So like between -2 and 2. You can pick more if you'd like. But I'm just going to stick to about -2 to 2. If I have an x value of -2, that's going to give me a slope of -4 if I evaluate it in that equation. And so every slope with an x value of -2, regardless of the y value, is going to have a slope of -4, and that's a very steep line. So every x, you're just going to draw a little dash that represents the slope at an x value of -2. Try to keep those all the same. All right, at an x value of -1, if I evaluate that in the equation, that's going to give me a slope of -2. So this one will be a little bit less steep, though very steep. And so just draw in some little -2 slopes. These will be a little less steep than that first one. At an x value of 0, of course, that means our slopes are all 0. So these are all just going to be little horizontal tangents. And let's see, an x value of 1 will give me 2, and an x value of 2 will give me 4. So it's going to just be a mirror image. And we can see that the farther you go from the y-axis, the steeper our slopes become. And that's going to create that parabolic shape. So, I forgot one right here. So we're moving more steeper as we move away from the y-axis. And then we could, depending on what our initial condition is, what our y-intercept is, we could trace these little slopes and draw that parabola. And I just threw in one there with a y-intercept of 1. On the next slide, this was generated by a TI graphing calculator. They will do that for us. You won't be able to use it on the test. It's not going to help you. But I'm just showing you this is what it would look like. This would be all the slope fields. And you can see how steep they are getting as you move away from that y-axis. This is all the possible solutions of that graph. Here's one, and it just tells us to sketch the slope field. It's on page 35 in your Cycle 3 packet. And so it doesn't say to come up with a general equation or anything. It just wants us to sketch the slope field. So I'm going to go ahead and draw me a table of values. This time I do notice that the slope is affected by both the x and the y. And the other reason you're drawing this table is to show your teacher and your AP grader the slopes that what you mean to be sketching on your graph. All right, so let's see, at an x value of, oh, well, first thing I notice is I've got a rational function. So anytime I have a y value of 0, I'm either going to have an indeterminate. Remember, when your x 0 divided by 0, that's in one of the indeterminate forms. Or whenever the x is any other number besides 0, an undefined value. So all values along the x-axis where our y value is equal to 0 will either be indeterminate or undefined. So now let's just take one of these other points on this grid. So I'm going to take the coordinate 1, 1. If I evaluate that in the function, that's going to give me a slope of -1. So I know that this point has a slope of -1. If I take 2, 2, that's also going to give me -1. 3, 3, That'll give me negative 1, and I can conclude that those are all going to give me negative 1. Let's just check a negative 1, negative 1. Well, that'll also give me negative 1. So all of the slopes on this diagonal will give me a slope of negative 1. Let's take the point, well, how about 1, negative 1? And you can pretty much start anywhere. I'm taking this point so I can look at the diagonal in the opposite direction. So if I have 1, negative 1, that's going to give me a slope of positive 1 because the double negative will give me a positive. And so I know that that point's going to have a positive 1 slope. And let's see, how about 2, negative 2? Well, that's also positive 1. How about negative 1, 1? That also gives me positive 1. All right, so you can see what's going on here. We have a positive 1 on all of these diagonals. And I can get more. I can check this point. You can do all the points on this grid. Let me show you the slope field on the next page. And we can see that the solution looks like a circle. Now, we don't know what the radius is, but if we had an initial condition, or if the graph said that it goes through a point, for example, 3, 0, we could plot that point 3, 0, and then follow those little slopes to draw our circle. Nice. This was just an example. All right, so why do we need slope fields? Well, because most differential equations can't be solved. Therefore, we can use a slope field to determine the behavior of the antiderivative, especially if we have an initial condition. Here's an example on a free response AP test. It says, consider the differential equation. Let y equal fx be the particular solution to the differential equation with initial condition 0, 1. So we have a point. We're going to plot that point. The function f is defined for all real numbers. A portion of the slope field is given. Sketch the solution. All right, so follow your little slopes. I think this is going to be like this. And on the left, these are definitely steeper. So it kind of comes down further. And I think as long as you're in the general direction, you're going to be fine. There are other methods that we will use in later courses to be more precise, but this is pretty much a good sketch of our graph. All right, so here's one like you'll see on a free response AP test. It says, consider the differential equation where x cannot equal 0, and it says on the axis as provided, sketch a slope field. All right, so we want to come up with a table of values that includes all of these points. So x, y, dy, dx. Your table might be pretty long. I'm going to start with just with negative 1, 0, negative 1, 1, negative 1, 2, 0, 0, 0, 1, 0, 2. All right, and then let's go ahead and evaluate in our derivative. So if I have, well, first thing I see, it's a rational function. So whenever my x is 0, these three right here, these will be undefined or indeterminate. So when I have my x value 0, I'm not going to have anything on this y-axis. All right, so that's easy enough. Let's take our x value negative 1. If I just have to plug it into the function. So if my x is negative 1, that'll square, and I'll have a positive 1 and 0. So how about negative 1 over 1? So that's negative 1. So the slope at this point, negative 1, 0, is negative 1. Okay, at the point negative 1, 1. Let's see, my numerator, those are going to cancel, so that's going to give me 0. So that's going to be a horizontal slope. In fact, every place where my y is 0, where my y is 1, I'm going to have 0 slope. So I can fill out those three. All right, so now we have negative 1, 2. And let's see, if I plug in negative 1, that's going to give me positive 1 in the denominator. And how about 2 minus 1 is 1, so how about 1? So I have a positive 1 slope there. And finish filling out my chart, 1, 0. So I'm just taking this coordinate here, plugging it into this equation here. So let's see. How about -1 right here? And for 1, 2, I believe that should be +1, and then 2, 0. So my denominator is going to be 4. My numerator is going to be -1, so -1/4. So we can see it's getting down 1/4. So it's flattening out a little bit more. And then at 2, 2. So denominator is 4 and +1, so 1/4. So here's my slope field. You don't want your AP grader guessing at what slope you're intending, so that's why we write out our table. All right, so here's another one. Consider the differential equation. Oh, find the particular solution. All right, well then this is just using separation of variables to do that. So let's rework through one of these examples. So let's see. I'm going to go ahead and multiply both sides by dx and divide by. So I have 1/y minus 1 dy is equal to 1/x squared dx. Okay, so I see that I'm going to have, well, I use substitution on the left. So I've separated, now I'm going to integrate. And so I'm going to say my u is equal to y minus 1, so du dy is equal to 1, so dy is equal to du. And so this is going to be 1/u du is equal to, and on the right side, let's go ahead and rewrite this with a -2. So this side will be x to the -2 dx. And so when I integrate, add 1, this is going to give me, well, goodness, I'm all over the place. Natural log of the u value is equal to, this is going to give me -x to the -1 plus c. All right, so natural log y minus 1 is equal to -1/x plus c. And if I have an initial condition of 2, 0, that means I'm going to go ahead and plug in 0. So I'm going to have natural log 1 is equal to -1/2 plus c. And e to the 0 is 1, so c is going to equal to 1/2. All right, I hope you're able to follow me there. And so now I'm going to go ahead and substitute in and solve for y. So here's like my next step. So I have natural log y minus 1 is equal to -1/x plus 1/2. Exponentiate both sides. And then get rid of the absolute value bars. And then add the 1. All right, so now we need to decide, do we use the positive or the negative? Using our initial condition, if we want our y value to be 0, we're going to have to subtract whatever this value is. And so our final answer is 1 minus e to the -1/x plus 1/2. If I did that right, let me just double check my work. 2, yeah, it should be a minus. We're going to subtract. All right, so find the limit. All right, so let's see. My equation was y is equal to 1 minus e to the -1/x plus 1/2. And find the limit as x approaches infinity of this function. Okay, so let's think about this. If our x is approaching infinity, I'm going to have 1 over a very big number. Well, that is going to go to 0. And so this is really 1 minus e to the 0 plus a half. So 0 plus a half is just 1/2. And so then this would be our limit. So in general, identify the following. When you're looking at, and I'm going to show you on the next slide, multiple choice with slope field. Where's the slope 0? Where is it undefined? Where is it going to be positive or negative 1? And just in general, where's the slope positive or negative? So let's take a look at this one. So first thing that, take a look at all the slope fields and then look at all your answer choices. We have one that's a natural log, one that's a product. Here something's going on when our x value is 2. When, and then these guys are exactly, when these guys are exactly the same, you're going to get 0. So just a few things to take a look at. The first one I want to try to guess at is this natural log one, because we know that natural log are only positive, are only defined for positive. In this case, natural log of y. So we're only going to have positive y values. You can't take a natural log of a negative. And so that one jumps straight to this answer here, because all of these are negative y values, right? So you can't take the natural log of 0 or negative numbers, and so this one goes to that one. All right, so the next one I want to look at is, well, I'll take a guess at this one. When these values are exactly the same, when our x is 1 and our y is 1, we get 0. And when our x is 2 and our y is 2, we get 0. That means we're going to have slopes that are 0 on the diagonal. And so take a look at this graph right here. Do you see that, like here's the 1, 1, here's the 2, 2, 3, 3. All of those are going to give us that 0 slope. And that's the only graph that does that. So I can go ahead and safely say that that one goes with that one. All right, so the next one I want to jump at is this x minus 2 one right here. And because when our x is 2, this whole thing is going to make it 0. So again, I'm looking right here at an x value of 2. I have nothing but 0 slopes. So that one has to go. And by process of elimination, that means this one's going to go with this guy over here.